This video goes over rational exponents. So a rational exponent is an exponent that contains a fraction. So something like 2 to the 1/3, 16 to the 1/2, or x to the 2/3. Those are all rational exponents. So let's take a look at the first example and we're going to evaluate the following. So the first thing that we're going to do is the square root of 16. So a number multiplied by itself twice, that equals 16. That answer is 4. The next one that we're looking at is the cube root of 27. So a number multiplied by itself 3 times, that is going to get you to 27. That number is 3. Example C, now we're looking for the cube root of negative 27. So a number multiplied by itself, that can get you to negative 27, and the answer there is negative 3. D is the fourth root of 16, so a number multiplied by itself 4 times, that equals 16. That number is 2. And now E, we're looking for the fourth root of negative 16, which would be a number multiplied by itself 4 times, that would get you to negative 16. In order to do that, I would need a negative number, but if I multiply negative 2 by negative 2 by negative 2, that's going to equal positive 16. So there is no solution to the fourth root of negative 16, which is true. Any even power or root you cannot do for a negative number. Let's consider the following. So if we have the square root of 16 times the square root of 16, we know that that's 4 times 4, which equals 16 to the exponent 1. Now let's replace the square root symbol with an x. So we've got 16 to the exponent x times 16 to the exponent x has to equal 16 to the exponent 1. Now we can use our power rules to note that because we are multiplying powers that have the same base, we can add the exponents together. So 16 to the 2x equals 16 to the 1. Because the bases are the same, the exponents have to be equal. So 2x equals 1, which means x equals 1/2. Let's do the same thing with the cube root. So 27 to the y times 27 to the y times 27 to the y has to equal 27 to the 1, as we've shown up here. Because we're multiplying powers that have the same base, I can add the exponents together, and I get 27 to the 3y equals 27 to the 1. Just like with my x example, because the bases are the same, my exponents have to be equal, which means that I get y equals 1. What we can say is that the nth root of a is equal to a to the 1 over n. So now let's do some examples. So 81 to the 1/2 is the same as the square root of 81, which is 9. Minus 32 to the 1/5 is the same as the fifth root of minus 32, which is minus 2. Now in C, I have a negative exponent. So the first thing that I want to do is rewrite it as a positive exponent. 81 to the 1 over 4 as a denominator. Now I'm going to rewrite my rational exponent as a radical. And that's something that I can solve. That's 3. So 84 to the negative 1/4 is equal to 1/3. Let's do a fractional example. So again, I notice I have a negative exponent. The first thing that I want to do is write that as a positive exponent. When I have a fraction, that is the same as just flipping my numerator and my denominator. Now that exponent applies to the numerator and the denominator. So I'm going to take the cube root of 27, which is 3, and then the cube root of 64, which is 4. Next example, E. I've got 125 to the 2/3. Now that looks a little bit different than what we were dealing with before because we have a number in the numerator of our rational exponent. No big deal. I'm going to write it as 125 to the 1/3 squared. Now inside my bracket here, I'm going to take the cube root of 125, which is just 5, and then I'm left with the squared, which I can evaluate easily. We've got another example with the same thing. I'm going to rewrite it as a rational exponent with a numerator of 1 raised to the exponent 5. Remembering our power laws, when I'm multiplying two exponents, or when I'm raising an exponent to another exponent, I can multiply them together. So now I can evaluate 4 to the 1/2, which is the same as the square root of 4. And I've got 2 to the 5th, which equals 32. Okay. So another statement is if we have a numerator that's not 1, so a to the m over n, we can rewrite that as n, the nth root of a to the exponent m. So let's do a couple more examples here. In example 3, we're going to write as a single power and then answer to 4 decimals. So 5 to the exponent minus 4/3. And using my calculator, I should get about 0.1170. Next one here, I've got 4 to the oops, 4 to the minus 3/6, which is the same as 4 to the minus 1/2, which I can evaluate without using a calculator as 1/2. My last one here, I've got 27 to the 5/7. Evaluating that is going to give me approximately, let's try that again there. Evaluating that is going to give me approximately 10.5294. Okay. And finally, you should be able to do substitution using fractional exponents. So in example 4, I'm going to use x equals 16, y equals 27. 16 for x to the 5/4, 27 for y to the minus 1/3. And now based on my knowledge of fractional exponents, I can evaluate both of those. So here I've got the 4th root of 16 to the 5. And then over here, I've got 1 over the cube root of 27, or 1 over 27 to the 1/3. So my first one is 2 to the 5 plus 1/3. So now I've got, let's see, 32 plus 1/3, multiplying that by 3, so I can add them together. So 32 times 3 would be 6. So I've got 96 over 3 plus 1 over 3 is going to give me a final answer of 97 over 3. One more example of substitution. I'm going to put in 27 for y. My first rational exponent is minus 3/2, and then I've got minus 2 over 9. So instead of evaluating my power first inside the brackets, I'm going to remember my exponent rules, and I'm actually going to multiply these two powers together. The reason that I'm going to do that is because my answer and my exponent is going to get a lot simpler. I can cross reduce right here, I'm left with minus 1, and I can cross reduce right here, I'm left with minus 1 and 3, and I'm going to get a simplified exponent of 27 to the 1/3, which I can answer as the cube root of 27, which is 3. Those are some examples of the skills that you should be able to apply using rational exponents.